Alright folks, today's lesson is about complex numbers. Complex numbers are numbers that can be written in the form a plus bi, where a and b are real numbers and I, as we know, is the square root of -1. What does that really mean? Essentially, complex numbers are a combination of real and imaginary numbers. The a represents the real part and the bi represents the imaginary part. So, the number 7 plus 3i would be an example of a complex number. 7 is the real part, 3 is the imaginary part. Two complex numbers can be considered equal if the real parts and the imaginary parts are both equal. The last part that I'll talk about is the complex conjugate. The complex conjugate is the difference between a and bi. So for example, if 4 plus 3i was my complex number, 4 minus 3i would be its complex conjugate. The product of the complex conjugates is a real number. Now this becomes very important when I'm trying to simplify complex numbers. Let's take a look at an example of why this happens. Let's look at our example of 4 plus 3i and 4 minus 3i. These are conjugates. If I FOIL, I get 16 minus 12i plus 12i minus 9i squared. Simplifying, I get 16, and check this out, my middle terms here cancel, and I'm left with 16 minus 9i squared. Now remember, a review from imaginary numbers, I squared equals -1. So this is really 16 minus 9 times -1, which turns into 16 plus 9, or 25. So, by multiplying the complex conjugates together, I was able to get a real number. And again, this will be very helpful when we start simplifying. Let's take a look at a couple of examples. If I'm asked to simplify complex numbers, I treat I just like a variable. So, in the first question, where I'm asked to write this in a plus bi form, I will go ahead and distribute 7i times 9, which is 63i, and then 7i times -6i, -42i squared. And again, I squared is -1. I'll write that up here so we can remember that. So this becomes 63i plus 42. And a plus bi, the real part, should always come first. So our final answer is 42 plus 63i. You try a couple examples and then check your answers. You should have gotten 12 minus 2, which is 10, 3i, and remember we need to distribute this negative, 3i minus 6i, which is -3i. So again, we're really just combining like terms here. In the second example, we combine the 4 and the 10 to get 14. -3i and +2i become -i.
That was easy.
Ha! Moving on to the next examples. Now, multiply and simplify. Again, we are going to FOIL. We'll see when I multiply my first two terms together, I get 30. I multiply my outside terms and I get -10i. My inside terms become 42i. And I multiply the last and I get -14i squared. Alright, combining like terms, 30 plus 32i, and again, I squared is negative 1, so this becomes plus 14. So my final answer is 44 plus 32i. All right, now it's your turn. Try the on your own problems and then check your answer. Now remember, when we see a binomial squared, this is really 7i plus 2 times 7i plus 2. I will square the first terms and get 49i squared. I will square the last terms and get 4. And then remember, I can multiply these terms to get 14 and then double it to get my middle term, which is 28i. All right, now it's time to simplify. I squared is negative 1, so this becomes negative 49 plus 28i plus 4. So my final answer is negative 45 plus 28i. The second one, I distribute 7i. Now it's time to simplify. 7i plus, and again, this I squared is negative 1, so plus negative 35. My final answer should be negative 35 plus 7i. All right, one last set of examples. Whoa! Hope you don't look like this llama. Okay, the last set of examples, we're going to use the complex conjugate to simplify. In the first example, we will need to multiply both the numerator and the denominator by the complex conjugate of the denominator. So check this out. I'm going to multiply the top and the bottom by 3 minus 4i. I'm multiplying it by 3 minus 4i, again, because that is the conjugate of the denominator. Now it's time to simplify. I FOIL on the top, and I get 15 minus 20i minus 6i plus 8i squared on top. And on the bottom, we know from our factoring, the difference of squares, we only need to multiply the first and the last term. So this is 9, and then minus 16i squared. I'll simplify a little bit more. Up top, I get 15 minus 26i. And again, I squared is negative 1, so this is minus 8. All over 9 plus 16. Almost done now, and I'll need to write my answer in a plus bi form. So all of this, I get 15 minus 8, 7 minus 26i, all over 25. So I'll write my final answer over underneath here. I have 7 over 25 minus 26i over 25. Notice I still have a real part and an imaginary part. All right, let's see that again. For the second example, again, I'll multiply by the complex conjugate of the denominator. So in this case, I'll multiply the top and the bottom by 3 plus 2i. All right, now it's time to start foiling. On the top, I get 9 plus 6i plus 18i plus 12i squared. I'll separate this problem. On the bottom, I get 9 minus 4i squared. All right, let's start combining like terms and cleaning things up. I've got 9 plus 24i minus 12i, minus 12. On the bottom, I've got 9 plus 4. Almost done. I combine my constants, so I've got negative 3 plus 24i all over 13, and I'll write my final answer over here. I get negative 3 over 13 plus 24i over 13. It's not pretty, but it's my final answer. All right, now you give it a try. Try the on your own problem and then check your answer. To do this one, I multiply the top and the bottom by the complex conjugate. 2 minus 3i, 2 minus 3i. All right, distributing them up top, I get 26 minus 39i, and on the bottom, I get 4 minus 9i squared. All right, 26 minus 39i, and this is 4 minus negative 9, so plus 9. 26 minus 39i over 13. It turns out that 26 divided by 13 is 2, and 39i divided by 13 is negative 3i. So my nice final answer here is 2 minus 3i. Well, folks, that's it. That's complex numbers. I hope you were able to follow along. If you need any help, come to class tomorrow with questions.